Welcome to The Explainer. Today, we're going to unpack a concept that's really changing the game in how we work with AI. We're talking about moving beyond just asking questions and into building these sophisticated guidance systems to unlock what AI can really do.
So, have you ever wondered why these incredibly powerful AIs sometimes just fail at simple stuff? Well, to get to the bottom of this, we're going to look at a fascinating story from an experiment by Professor Hung-Gee Lee. It perfectly shows how even a smart AI can get things spectacularly wrong, and why the fix isn't what you might think.
All right, so the experiment involved this tiny model, only a 2 billion parameter version of Google's Gemma, and its mission? A seemingly straightforward coding task. Find a bug in a file and fix it. Okay, so the setup here was super simple. The AI had all the tools it needed to read files, write code, and run tests. And the files it needed were sitting right there in its working directory. Should be a piece of cake, right? Well, not exactly. And on its first attempt, oh man, it was a spectacular failure. The AI didn't even bother to look for the file. It just straight up said it didn't exist, hallucinated its own version from scratch, tested that, and then proudly announced, task complete. I mean, talk about being confidently incorrect. But here's where things get really interesting. The researchers didn't throw a bigger, badder model at the problem. Nope. The only thing they changed was adding this tiny 80-word instruction. And this wasn't some cheat sheet, It was just a few general principles on how to think about a task. And what happened? Boom. Just like that, with that little bit of guidance, the exact same model nailed it. It listed the files, found what it needed, read the code, fixed the bug, and verified its work. A total success. So, what was the difference here? It wasn't the model's brain power. It was the guidance it was given. And this, right here, is the core idea we're digging into today. Sometimes it's not about having a smarter AI, but a better guided one. And this whole idea of building a guidance system around an AI, well, it actually has a name. It's a field that's becoming incredibly important, and it's called harness engineering. So what is it? Basically, harness engineering is all the stuff you build around the language model to guide it through complex, multi-step jobs. It's the framework, the workflows, the tools, everything but the model itself that helps it succeed. And I love this metaphor here. The AI is like this incredibly powerful wild horse. It's got all this raw energy, but without a harness to guide it, that power is just chaos. The harness is what lets us direct that energy and get something useful done. And just to be clear, this is different from what you might have heard of before. Prompt engineering is all about asking the perfect question to get one good answer back. Context engineering is about feeding it the right documents. But harness engineering, that's about managing the entire process, the whole back and forth, to get a big, complicated task done right. Okay, so that's the what. Let's get into the how. How do you actually build one of these harnesses? Well, it pretty much boils down to 3 key methods. You can control how the AI thinks, you can define what it's allowed to do, and you can lay out the exact process it has to follow. Let's break each of those down. All right, first up, cognitive frameworks. This is exactly what those 80 words were in that first experiment. It's basically like giving the AI a constitution, a set of laws written in plain English that it has to follow for every single step it takes. Second, you can define its capability boundaries. This is all about controlling the tools you give the AI. It's like deciding what to put in its toolbox. And this leads to a really important trade-off, right? Convenience versus safety. So take something like OpenCopilot, which runs right on your computer. It's super convenient, it can access anything. But that's also a big security risk. Then you have something like Kuros, which runs in a safe little cloud sandbox. It's way more secure because it needs your permission for everything, but it's also a lot less powerful. And get this, it's not just which tools you give it, it's how those tools are designed. There's some great research that shows if you give an AI a tool made for humans, like a search page with a next button, it actually does worse than if it had no search tool at all. It just doesn't think that way. It needs tools built for its brain, like something that just gives it a full summary all at once. That works way, way better. And method number 3, establishing a standard workflow. This is like giving the AI a strict step-by-step procedure it has to follow every time to ensure consistency. A really cool example of this is the Ralph loop. Okay, the Ralph loop is just genius. It's this awesome cycle of improvement. The AI tries to do something, say write some code. it gets an automated error message back, then the harness automatically reprompts the AI with the original task and the error, basically saying, hey, try again, but don't make this mistake. It keeps doing this until it succeeds. The coolest part? It's all automated. The AI is learning from its own mistakes in real time, without a human needing to step in. And this idea, this ability to learn from feedback on the fly, it's way more than just a neat trick. It's really the key to the future of AI agents. This is a whole new kind of learning. Some people call it textual gradient descent, which is a fancy way of saying the AI changes its behavior based on feedback in the conversation, right there in the moment. It's not being retrained from scratch, it's learning and adapting on the fly. So why does all this matter? Because we're moving from a world where AIs are just one-off tools to one where they could be long-term companions that grow with us. The harness is what's going to manage decades of memory and allow them to learn continuously right alongside us. So, when you boil it all down, the big takeaway here is this. The next leap in AI capability might not come from a bigger model, it might come from a much smarter harness. And that leaves us with one final thought to chew on. If we're the ones building the harness and we're the ones providing the feedback, what should we be teaching our AIs? As we become the main guides for these powerful new minds, the responsibility for what they learn and what they ultimately become, well, that rests on our shoulders.